Prahlad Sahu from Group 10. This is our assignment 2 for MLOps course, an end-to-end MLOps pipeline for binary image classification, cats versus dogs. Let me walk you through the pipeline overview. The pipeline covers all 5 modules. Module 1, model development with experiment tracking using DVC and MLflow. Module 2, packaging the model into the Docker container with the fast API, REST API. Module 3 is continuous integration with automated testing and image builds. Module 4 is continuous deployment to a Kubernetes cluster. Module 5 is monitoring with the Prometheus metrics and Grafana and post-deployment evaluations. Let me walk you through each one live. Let me give you a live demo of Module 1, model development and experiment tracking. Here is the Git history for our project. All code changes are version controlled. The dataset has 25,038 images, about 849 megabytes. It is tracked with the DVC. Git stores just this small metadata file, while DVC handles the actual data. The model code. The model is a CNN with 4 convolutional blocks, batch normalization, dropouts, and a fully connected head. It takes 224 by 224 RGB images and outputs 2 classes, cats or dogs. Pre-processing. Pre-processing resizes the image to 224 by 224, splits it into 80 by 10 by 10 training, validation, and test sets, and applies the data augmentation. The MLflow UI. MLflow tracks every experiment. Here you can see the logged parameters, learning rate, batch size, epochs, the metric training and validation accuracy, loss, precision, recall, F1 score, and under the articles, the confusion metrics and saved model file. Now let's go over module 2, model packaging and containerization. The inference service. The trained model is wrapped in a fast API, REST API. It exposes 4 endpoints: health check, single prediction, batch prediction, and a metric endpoint for Prometheus. The Docker. The Docker file packages everything, dependencies, source code, and the trained model into a single image. It's already built at 2.59 gigabytes. Let me spin up a container and hit the health endpoint. Status is healthy, model is loaded. Now a real prediction. I am sending a cat image. It correctly predicts cat with a class probability. Now let's go over module 3, the CI pipeline. Unit test. We have 14 unit tests covering pre-processing and inference, test for image loading, data transforms, the dataset class, image pre-processing, prediction, model creation, and output shape. All 14 passes. CI configuration. The CI pipeline runs on every push or pull request. It checks out this code, installs the dependencies, runs the PyTest with coverage, build the Docker image, push it to the GitHub container registry, all automated. Module 4, CD pipelines and deployment. Kubernetes manifest. The Kubernetes deployment runs 2 replicas with liveness and readiness probes on health endpoint. Resource limits are set: 512 meg to 1 gig of memory, 250 to 500 millicores of CPU, a node port service exposed to port 80. CD config. The CD pipeline triggers on push to main. It creates a kind cluster, builds the image, loads it into the kind, deploy it with kubectl, and runs the smoke test automatically. Live deployment. Here's a live cluster, 2 pods running, the service exposed, the deployment healthy, 2 out of 2 replicas are available. Let me hit the deployed service with a dog image. Prediction dog with high confidence, real data through Kubernetes. Smoke test. The smoke test script validates the health endpoint, the metrics endpoint, and makes a prediction call. Module 5, Monitoring, Logs, and Evaluations. Prometheus metrics. The app exposes Prometheus metrics. Here you can see the total request count, latency histogram, prediction counts broken down by class, cat versus dog, application logs. Structured logs from the pods show every prediction with its confidence score and latency in seconds. This gives full visibility into what the model is doing in production. Post deployment evaluation. Finally, the evaluation script sends the real labeled image to the deployed API and computes accuracy, precision, recall, F1, and a confusion matrix. In Prometheus, I run inference request total to confirm the live API traffic. Then I query the P90 latency metric to monitor the real-time inference performance. In Grafana, this dashboard visualizes the inference request total for traffic monitoring and prediction total to track the prediction distribution across the classes. This validates that the model performs correctly after deployment, not just during training. Summary. That's the complete MLOps pipeline from data versioning with DVC, model training tracked by MLflow, containerization with Docker, CI/CD through GitHub Actions, deployment to Kubernetes, and production monitoring with Prometheus and Grafana. 5 modules fully automated end to end. Thank you. This is Prahlad Sahu from Group 10.